Section 2.5, Compound Inequalities. Objective 1, finding the intersection of two sets. So the intersection of two sets A and B is the set of elements common to both sets. So basically you have two sets of things. It could be a set of colors and a set of shirts, and then what do they all have in common? So example 1, we're going to change this to an upside down U because that's what intersect is. That was just a typo on my part. So for number 1, we want to find the intersection of 1, 2, 3, 4, 5 and 2, 4, 6, 8. So it's basically, what do they both have in common? Well, they have both 2, 4, and nothing else. So the intersection of these two sets is 2 and 4. Alright, objective 2. Solving compound inequalities containing and. So we're going to solve each compound inequality, graph the set, and write the solution in interval notation. Okay, so for A, we have x is less than 3 and x is greater than 7. So first let's graph this, because it'll help us write an interval notation. So it says we have x is less than 3, so we're going to the left, and then it states that x is greater than 7, so we're going to the right. So these don't meet. They don't meet. So we can't put them in interval notation like this. We have to union it. And I'll tell you what it means. So first we have negative infinity to 3. So that's negative infinity to positive 3. And we're going to union that because we have 7 to infinity. So 7 to infinity. And there would be our interval notation. Next, we're going over B. So B is negative 1 is less than x minus 4. That's less than or equal to 5. So you see we have two parts here. We have the middle is greater than negative 1, and then the middle is less than 5. So we're going to break it up. So we have negative 1 is less than x minus 4, and we have x minus 4 is less than or greater or less than or equal to 5. So we're going to solve each. So add 4 to both sides. We have 3 is less than x. Add 4 to both sides. We have x is less than or equal to 9. Now let's graph these. You could have done this without breaking it up, and if you want to do that, by all means, go ahead, but I'm just showing you step by step. So let's graph this on our number line. We have 3 and 9. So our first one states that x is greater than 3. So greater than 3 is to the right. Our green one states that x is less than or equal to 9. So that's a bracket, and less than means left. So they come together. That's why that's an and. They come together. Moving on to C. So C states we have negative 6 is less than or equal to 2 over 3x plus 5. That's less than 9. So just like before, we have 2, so we need to break it up into 2. So we have 2/3 x plus 5 is less than 9. And we have negative 6 is less than or equal to 2/3 x plus 5. So we're going to solve both of these. We're going to subtract 5. So we have negative 11 is less than or equal to 2 over 3x. Multiply by 3 over 2 to get rid of the fraction. So we have negative 33 over 2 is less than or equal to x. Do the same thing to the green one. We're going to subtract 5. So we have 2/3 x is less than 4. multiply by 3 over 2. So we have x equals, is less than 12 over 2, and 12 over 2 is 6. So we're not going to graph this one. We're just going to write an interval notation. We have negative 33 over 2 and 6. We know that they come together because if you notice, anything where the signs are pointing in the same direction in a compound inequality, they're going to come together. Alright, last one, D. D states we have negative 2 is less than 2x plus 1 all over 5 is greater than 4. So we can go ahead and get rid of this fraction. Remember, anytime we have fractions, we can get rid of them by multiplying by the LCD. So the only denominator we have is 5. So we're going to multiply 5 to everything. So we have 5 times negative 2 is negative 10. That's less than, when you multiply the LCD by the LCD, like to it, it gets rid of it. So we're just left with 2x plus 1. And then 5 times 4 is 20. Now, it's a lot easier to work with, and we can break it up. So we have 2x plus 1 is less than 20. And negative 10 is less than 2x plus 1. So we're going to solve for both of these. Subtract 1 to both sides. We have negative 11 is less than 2x. Divide by 2. So we have negative 11 over 2 is less than x. Same thing over here. We are going to subtract 1. So we have 2x is less than positive 19. Divide by 2. So we have x is less than 19 over 2. Since it's a compound and the equations are going in the same direction, we can go ahead and do negative 11 over 2 and 19 over 2. Alright, objective 3. Finding the union of two sets. So the union is different than the intersection. The union is, if we combine the two sets, what's going to happen? So example 3, if A is 1, 2, 3, 5 and B is 1, 4, 7, we want to union A and B. So the union of A and B, we're going to just put them together. So we have 1, 2, 3, 4, 5, and 7. You don't repeat any numbers. You just put it all together and don't repeat anything. Alright, objective 4. Solve compound inequalities containing OR. Alright, so A. We have x is less than 3 or x is less than 6. Let's graph this. 6 and 3. So for less than, it's saying that it's going to the left. Same thing. It's going to the left. Now which one of these answers would it be if you write this in interval notation? We can't put 3, 6. We can't, there's nothing to union. So we're going to say it's going from negative infinity to positive 6. Because we want to include any values that are less than this 6. Alright, last one. So we have 7 times x minus 1 is less than 8, or x plus 1 is greater than 4. So we distribute. We have 7x minus 7 is less than 8. Subtract 7x. Nope, sorry. Subtract 7. It happens. Add 7. So we have 7x is less than 15. Divide by 7. We have x is less than 15 over 7. Same thing here. We subtract 1. We have x is greater than 3. Now 17 or 15 over 7 is 2 and 1/7, so it's less than 3. So that means if we want a number line on this, we have 3 and 15 over 7, which is 2 and 1/7. So it's saying that we have to have less than. So less than means we're going to the left. And then next, it says greater than, so we're going to the right. And if we want to write that in interval notation, because they're not coming together, we have to union it. So we have negative infinity. It's a 15 over 7. Union that with 3 to infinity.